Good evening, electronics friends. Trying to figure out how to start these videos, but I think maybe I'm going to start doing a series of videos about electronic projects that I come up with, various things I'm working on. There's even a couple of things sitting on the workbench right here. But this episode, it's time to move and improve the lab back to my original workbench built some 35 years ago. It's been a while, and that should give you a bit more about my age. I think I was a teenager when we built this, and it was really kind of some hacky kind of stuff that I was playing with. Then I went to college and got a degree. Unfortunately, that didn't quite work out, but we won't get into that too much. The quickie, low-down, dirty, whatever. I set up some switches and I had some things mounted. I have done some cleaning up of the workbench. I pulled out a bunch of stuff. You can see how the wood has aged over the years here in the garage from the stuff that I had mounted on there. But I have been going through a lot of my old electronic stuff, sorting, just figuring out kind of how I'm going to put it all together. I mean, I've got one of these 24 compartment boxes filled with resistors. I've got another box with a bunch of capacitors and inductors. I've got a box full of chips. Actually, two boxes with chips. One's just 7400 series, which again will date me a bit. And you know, I've got my old soldering iron here. I've got a pair of reading glasses, which helps me get up close and personal to the work. I've got this thing here, which is something I started working on and then had to kind of quit like a week ago. So there's stuff to do here, but the first thing we're going to need to do, well, first of all, let's put some light on the subject. This switch here, I've pulled out a bunch of switches. This is just an indicator light that was supposed to say, hey, there's power on the bench. I've not hooked that up. This is a lighted switch, but it's not hooked up as a lighted switch. It's just simply a switch. But what that does for me is turns on the lights up above. Yeah, there you go. That's enough of that. So the first thing is I'm just going to completely clear the workbench because I have something I want to get set up. So here we go with that. Okay, so that's most of it in a box, just so I can get it off and put away for temporarily. Okay, so that's still a little bit better, but there's one more thing we can do. We can move the camera mount from the old temporary workshop to the new workshop. Okay, now before I do this, it occurs to me I should just show you what the camera mount actually looks like. It's literally just a board with a cell phone adapter, because this is a cell phone, which camera I'm using. And it's literally, I'm just going to stick it up on a shelf, kind of like that. And I'm going to have to pull it back down so it doesn't fall, and use a C-clamp to hold it on. I could use other things. I could even just screw it to the shelf. For the moment, I'm just using the clamp. If I need a clamp for something else at some point, that'll be a project, just simply screwing it down to the shelf. In fact, maybe I'll just go ahead and do that. Let's see. One cordless screwdriver and decking screw later. I'll put the decking screws away, off to the side, and I've now got it mounted, so let's see what it looks like. What do you know? I think that's actually going to work. I can go put the clamp away. Okay, so now the next thing is, let's say, put the cordless screwdriver away, actually put the bit back in the screwdriver so I don't forget it. I've had the soldering iron warming up for me. And I have this little board here, which is just a random board that I picked up at local surplus electronics shop called All Electronics, and that's not an endorsement per se, but I do like the guys. I wouldn't have a problem if they wanted me to, if they wanted to do a sponsorship. Actually, now that I'm looking at it, that's a little bit off kilter. Let's see if we can't straighten that out a little. Oops, I'm a little off. Let's fix that. Okay, let's see if that's a little bit better. Now I should be able to have a little bit of adjustment so you're not looking at I get to do it again. You know what? Let's just go ahead and do this live. All right. But what I'm honestly trying to do is just right along this border here, which you can't really see. Right along this side here, I was trying to get it lined up because when it was like that, you're looking at the floor. I want to keep it kind of nice and straight, a la Big Clive. Let's see if we can't tighten it up a little bit and make that. Whoops. Alright, battery's dying on the cordless. Alright. So you ever wondered how the guys do this with the overhead view? Well, that's how they do it. At least that's how I'm doing it. So, there we are. I'm going to put that away. I'm going to put that away because I'm trying to keep the workbench somewhat clean. But obviously, if you start doing lots of projects and stuff and you got a workbench, the first thing you need is the workbench itself. But, alright. So I started talking about this board here. And the idea with this board, it's just a random board that I picked up. It's got a switch on it, and it's got a bunch of old LEDs. So I've already harvested a couple of LEDs off of it. I've got a green LED here. I've got a red LED. And simplest way to test LEDs, if you don't have a tester, is a button cell. Generally a 3-volt button cell. This is a 2032 if you care. And you can just try the two leads of the LED. Now, granted, let me sort of show you this, hoping that'll come through. It's probably way out of focus, but hopefully you can kind of see there's the two leads there. They're both cut. It's hard to know exactly which one's positive, which one's negative. Fortunately, with a small battery, you're really not going to do much damage with a cheap LED. If you had some really super expensive LED, I wouldn't necessarily do this, but let's see. If I hook it up across these two, it's not lighting up. So that's the wrong polarity. If I get up this way, okay, that's not right. Back to back to the original. So hopefully that'll come through. The problem is the leads are so short that I'm having to kind of put them up against the battery. I'm hoping I can get it there. Hopefully that's coming through, that it's lighting up. So that's what I'm going to end up doing. I'm going to take this LED. This is going to be part of the first, well, you know what? We'll make this a twofer. This video is going to be, the first project is cleaning off the workbench and getting the camera set up. And the second one is going to be setting up, and it may take a little while. I'm not going to go through desoldering from this. But what I really want to do is I want to set up 2 power supplies on the workbench. Now that board that I showed you that's right up here that you can't really, there we go, I can kind of get it into view. Ooh, that tells me my camera's not exactly lined up. That might be better. We'll find out in post-production. I want to ultimately put power rail for both 12 volts and 5 volts because I do mostly low voltage type projects. I want to put these up on here. I have kind of a plan for this big hole right here, but I think what I'm going to do is right around here is where I'm going to put my voltage rails. So I had to look through some parts, miscellaneous parts that I happened to buy years ago. This is a terminal strip. I'm kind of show you what that looks like. And it's got these screws here that you can screw down to capture, let me see if I can, yeah, on this side. So you can see what looks like holes. Basically you stick the wires in the holes and you turn the screws to tighten down on the wires. And each one of them has a pin. So ultimately I'm going to take these pins and I'm going to hook them onto an old surplus circuit board that I happen to have. I think what I'm going to do is I'm going to take this and I'm going to set it up for both 5 volts and 12 volts. Let me see if the pins actually fit in the holes. Oh, baby, it fits beautifully. So I can set that one up there. I've also got this other style of terminal strip. And let me see if I can, yeah, I got to turn it that way so you can see the little levers fall. And so the idea with this one is that the wires go into the little receptacles there, and then you push the levers in to clamp down on it. So, and this also has the pins on the back. So I can make this a terminal block for 5 volts, and I have another one for 12 volts. So if I consider the first one as ground, I've got to figure out how I'm going to do this here. Ground. Actually, I think I'm going to do it a different way here. Okay, I'm going to put ground down here, roughly centered. So that'll be my ground plane. Then I can have a 5 volt plane, 5 volt rail, whatever you want to call it. Basically, a place where I can put wires to hook up things for 5 volts. And I'm going to do it kind of logically here. I'm trying to get the holes lined up. Yeah, that looks good. So I can set up the 5 volts here. I can do the same thing for 12 volts up here. I'm trying to get it lined up and pushed in. There we go. Nice. So this is what the whole thing is going to look like. And the reason I did it the way I did it is because I don't know why I just kind of want this hole on the left here. I want that to be on the left so I can ultimately mount it up on this board. So I'll be able to just hook up various 5 volt and 12 volt. Actually, I now see a problem. This is why I'm glad I haven't soldered anything in yet. Alright, I'm going to have to pop this out. I'm going to have to choose, say, here. See if this will work. The problem is they're lined up so close to each other as I had it before that I wasn't going to be able to really fit the wires in there too easily. So I'm going to offset these. I'm going to make one go all the way to one side. If I can get it. Oh, you know what? I'm missing a hole here. Okay. I'll have to come up. That's what you get with a surplus circuit board. It's not necessarily laid out exactly the way you want. So let me get that pushed in. There we go. That's in. Now we've got the 12 volt. I'm going to move that over to the left. And so now it's staggered. It should be a little easier to work with. There's a little bit of overlap, but honestly, I think I've got 10 connections for ground down here. I've got 8 for 5 and 8 for 12. I can write down 5 here and 12 up here so I know which one is which. It'll be up on my board here. I'll be able to use this to hook things up. Also, I should point out on the back, it's an actual circuit board, so it's got circuit traces. So I've got to make sure that all those circuit traces are cut, the ones that run between one and the other, so that I don't end up hooking up the 5 volts to the 12 volts or shorting 5 volts or 12 volts to ground. So I'm going to have to check all of that and inspect it. But ultimately, what I'm going to do is solder everything together. The other thing I wanted to do, the reason I brought out the LEDs, is I'm thinking I can put the red LED on the 12 volt and the green LED on the 5 volt, so I have a visual indicator that the power is on and I can remember which one is which. It's probably better to just write it down to begin with, but it's also just kind of nice to have a visual indicator that the power is up and running. So the only problem with that is it doesn't look like these holes are close enough together although there are some holes down here. Let's see. There's some additional holes which are obviously set up for transistors. Okay, I may not be able to use these surplus LEDs. I'll put them in my box full of LEDs, and I'll pull out some other LEDs to use. So I'll come back to that, but ultimately that's the plan. I'm going to solder all this together, and then I'm going to hook it up on the panel here, and I'm going to hook a 5 volt and a 12 volt source to it, and then I'll be able to do projects or be able to do experiments to figure out my projects for 5 volts and 12 volts. So that's the idea. So I'm going to go ahead and get that started. I'll come back when it's done. Okay. Harbor Freight, $10 Drill Master rotary tool with a cutoff wheel, which has actually been used on some stuff, but should be just strong enough for me to cut the traces here. So here we go. Okay, that should be enough to disconnect everything. I need to clean that up a bit. Should be able to disconnect the 12 volts from the 5 volts from the ground, so they're not shorting each other out. But the simple test on that, and I gotta tell you, I've had different voltmeters over the years. I'm not recommending a specific brand, but if you can find one that has a beep function that you can use for continuity. Let's see, can you actually see the display if I do that? Not really. Alright. But I have the audible, you have the visual. So all I'm going to do is just connect between here and here. Nothing. Good. Now here and here, nothing. I'll try a couple of different points. And that should be successfully disconnected. Alright. I think we're good. Just to prove, it does when I connect them. That is so valuable. I've always wanted to have it, and recently I got one that has that function. Makes my life so much easier in testing continuity on things. I really need to recommend this to a buddy of mine who does maintenance at my old apartment building, because we went through a whole thing about how to diagnose the heating elements on a water heater because they were electric, and you know, the pain when they would burn out and people would complain. I lived there too. But people would complain that their water heater wasn't heating up the water, and so it became a question of, was there a problem with the water itself, or was it a problem with the heating elements, or what was the other problem we ran into? Oh, sometimes it would literally just be like, they were electric water heaters. Sometimes it would literally just be like a blown, the circuit would have tripped. And the circuit could trip for different reasons. It doesn't necessarily mean there's a defect in the water heater, although you definitely want to check it out if you have it tripping, especially if it trips more than once in a short period of time. But I mean, sometimes it was just, there was a power outage or something, and there was a surge when it came back on, and maybe they weren't at home when all of that happened, and they didn't put two and two together. You don't expect them to. Not everybody's an engineer or a technician. So, but poor guy just, I mean, he's figured out. I tell you, honestly, my buddy is a musician first, or was a musician first, and then, you know, after he kind of retired, he fell into doing maintenance. And I'm not saying the musicians can't figure out things. Look at Tom Scholz, leader of the rock band Boston. Look him up on Wikipedia. He was a mechanical engineer, learned electrical engineering, built up a company doing special effects pedals for rock musicians. Well, probably more than just rock musicians, but by no means am I saying that musicians can't handle engineering, but this guy just didn't really know engineering and wasn't interested in spending all the time understanding how resistance works and all the rest of that, so that's kind of where that went. But now I've tested that, I wanted to show you, this is it's amazing the things I find after 30-something years. I moved away, I'm now back home, and I'm now back to my old workbench, and I've got this hookup wire, this really thin hookup wire, and it's been absolutely wonderful because what I can do is I can just tack the wire on. You could also do this with what they call magnet wire or transformer wire. Although that's coated, this is uncoated. But if I do it right, nope, not quite, almost. If I do it right, I can get it to join onto that one, and then I can run it across and join onto that one. Of course, it's bare wire, so it gets hot. Okay, now I'm connected onto that one. So basically I've got that, and then I can just tack into all of these other connections across, and now they're all connected together. I can do that for all three of these. So that's what I'm going to go ahead and do. Now you get to watch time lapse. Okay, final step, I'm going to check to make sure that I don't have basically no shorts between the different rails. So between here and here I shouldn't get anything. I'll try a few different ones. I'm good there. Between here and here I'm not picking anything up. Now, by process of elimination, that should cover all three, but just to be sure, I'm going to hook up here, make sure that 5 and 12 don't connect. We're good there. Alright, let's take care of something I've been meaning to do. Five volts. 12 volts, and why not? Ground. So now I've got those marked. What remains is to get some LEDs and set up some kind of circuitry to show that there's power to each of the rails. So let me go take care of that.